Yes, we have a problem in this form or in this arrangement. So here we are to find what is the acceleration of the system shown below. So this is a system, particularly inclined plane, carrying different masses with a tension T, and we are also looking at the arrow tending downward to show the direction of the acceleration of the system. So how do we solve this problem? And the first method, or the best way in solving this problem, is by attending to different masses carrying by tension T on the system or on the inclined plane. So how do we do that? So the first thing is to, let's have this one this way, that is weight that will act on this mass of 30 kilogram. Remember that you have a weight W equals to mg, so we can as well say that the 30 multiplied by g. So or we have if you take the g to be 10, that means we have 300 here, that is 30 times 10, so we have a 300 newton here. So let's try to free this section of the body out of the whole system. That is, I'm trying to free this system out of the whole system of forces we are having here. So we have this very structure, that is the free body diagram of 30 kilogram. This is 30 kilogram, which we have converted to 300 newton here by weight equals to what, mg. So here is 300 newton. Then there is a tension on the rope or on the cord, which is t. Then the acceleration is tending downward in this case. So to now write the balance equation for this kind of expression here, so we can have, this one is tending downward, we can say t minus 300 to balance the effect of force on the body equals to, since this one is tending downward, we can say the net force here will be negative of F, which is equals to minus of ma. So from here we have a minus t minus 300 equals to minus ma. Remember that our mass equals to 30 kilograms. So 300 here equals to minus 30 a. So you can as well say that that's 30 a equals to 300 minus t. That is, we multiply all through by minus. So from here we can have it to be that t equals to, let this one come here and this one to this direction. So we have a 300 minus 30 a. So this is equation 1 for that. So now for this system, for this system, so what we do is this: we have detached this one already from the whole system. So we have this system. Let's try to draw it here. So we draw this simple system here. So here we have 20 kilogram here, 20 kg here. We also have a tension tending or trying to move the body up the inclined plane, that is tension T here. So here we have a 30 degrees the angle. Now then, this place, nothing is happening there. There is something happening there, but we are looking at it very soon. So in this case now, since this force is pulling this body of 20 kilogram up this inclined plane, then there must be a force along this line trying to counterbalance the effect of t here, pulling it upward the inclined plane. So also we have a normal reaction to the body on the inclined plane. So we call that normal, we call it what, r. This is normal r to the system. Then also another force, we tend to balance this normal down to the earth, which is also W weight, which is also equals to mg. So that will give us m is 20 in this case. Here is 20 times our g here. Let's say g equals to 10. So that is 10. So here we have a 200 newton trying to balance up the system. So having gotten this idea, now if we project a line to be in opposite direction to this r, so this one is drawn this way to r. So I've been able to draw the line along the same line with R here. So let's say this one is tending downward to counterbalance the effect of R here. So having gotten that now, so now from the geometry or our analysis of inclined plane, the angle 30 degrees here is also equal to this angle 30 degrees here. Maybe in the next video I will show us how we arrive at this 30 between this weight and this line 30. So to now draw the free body diagram for this whole system, so let's draw it here and see how to resolve the W of 200 Newton to this side of the line. So let's free the body here. So I'm doing this free body here. I'm doing it here now for you to see clearly. So here we have this. This is the normal, which is R here. This is the tension on the inclined plane as T. Then also this is another tension here yet to obtain. So let's call this one X in this way. So we're having X here yet to obtain here, X. So this is the line I projected with this normal reaction R. So for this very one now here, I'm putting the stuff here this way. Can you see now? So this is W equals to 200 Newton. Now for this angle here, the angle will be here also as 30 degrees here. So I haven't gotten this idea. This is where we want to resolve the 30 degrees to. So let me try to complete the triangle of this one. So far I've called this side X. I'll call this place X2. That means anything I get here will be equal to this side. It's like a size of a rectangle. So this is opposite over hypotenuse. So I'm having a sine of 30 equals to the X now over 200. So here we have this is over 1. That is X now times 1 equals to 200 multiplied by sine 30. So X now equals to this times this. That will give us 100 here. So I call this one 100 Newton here. So that means I have been able to get the force along this line, or force along this line, force or tension along this line. So I'm putting 100 Newton here. Look at it. I'm also putting that 100 Newton here. That is the total form of force I have obtained already. So now for me now to get the whole system now, to balance the whole system, remember that this acceleration turning downward here also starts from here, moving in this direction, then coming down to this direction. So that means my acceleration here now can be obtained by saying the force acting here equals to M of A. So that means this one is tending, look at it here, this T here is tending towards positive direction. Here is minus, and I'm having my force in this way moving here, F equals to what? MA. To now write a balance equation for the system now, I can as well say that my T minus 100 here is equal to my force, which is equals to what? MA. So T minus 100 equals to the mass on the system is equal to what? 20 Newton, which is here. So I'm putting it here now, 20 times A. So T minus 100 equals to what? 20A. So I haven't gotten that, so I can say T now equal, this is my equation 2. So T now equals to 20A plus 100. So far this one equals to this, and also the one I got earlier, which is equal to T equals to 300 minus 30A equals to this. So T is equal to the same T here. So I can as well equate this one and this one. So I can say 300 now minus 30A equals to 20A plus 100. So here I'm having 300 now minus 100 equals to, let this one come here as this one moves towards this side. So that will be 20A plus 30A. So that will be 200 equals to 50 of A. So here now I'm looking for A now. So we divide both sides of the expression by 50. So here is by 50 here, and here by 50 here. This will go for this. Therefore, A equals to 200 over 50. So A equals to 4 meter per second. So the acceleration of the whole system now, come back here. the acceleration of this whole system here, as we are tried as we are told to find, is equal to 4 meter per second, 4 meter per second squared. That is the solution for the acceleration. So like the video and also subscribe for more. Thank you.